Motors from EMAX, the LS series. So these come in 2206 and 2207 sizes, and they have pretty much covered all the spectrum of kV values for both motors. So we got the 2206 2300 kV on the low end, 2206 2700 kV, that's the high end, and 2206 2550 kV, the mid kV value. And for 2207 we started at the low 1900 kV, so this should be good for up to 6S, no problem with 5-inch props. Then for the mid value we got 2207 2400, and for the high value for this size we have 2550. So they decided not to do a 2700 kV, possibly because they think it's just a little bit overkill for the 2207, though some people do run them on 2207, but 2550 is somewhat mid-high kV, I guess. That should be a good motor. So thanks to EMAX USA for sending these motors for testing, so I can put them on the truss stand and tear them down and show them to you guys. So thanks EMAX, much appreciated. So I'm gonna be testing all these motors one by one. I have to put them on the truss stand and see how they perform on the truss stand and how they compare to other sizes like the 2306 or 2206. So it'll be an interesting comparison for these light spec motors. The usual, you know, I'll do the usual props, 5-inch and a couple of 6-inch props on 4S mostly. For some of the motors I've started to run 5S, as long as I can see that it's not gonna fry my ESC or my truss stand. So I'll do 5S for some of them on the light prop on the HQ 5040x3. So that'll give you more or less an idea of what the motors do, since I've tested other motors on 5S with that same prop. So it's good to compare motor to motor. Although keep in mind that in the truss test, since it's static, the amps are going to be a little bit exaggerated, a little bit high. Also the truss is going to be higher than what you actually get. But since I keep everything consistent as much as I can with the power supply, you can make pretty good comparisons from all my tests. When you look at the amps for each of the tests, don't let that high amp fool you. You know, it's kind of exaggerated. You know, that's not the actual amps that you're gonna get, because you got to keep in mind that I'm using a power supply that keeps the voltage pretty steady at almost nearly. I start at 16.1 volts, so it keeps the voltage pretty high throughout the test run. In comparison, when you're running a LiPo that's powering 4 motors, when you throttle up, the voltage goes down as the battery discharges, and as the battery sags, the voltage sags, you know, and as the battery heats up, also there's more resistance. So there's gonna be lower amps in the air. So it doesn't mean that the amps you see here on the truss stand, that's what you're gonna get when you fly. It's gonna be considerably lower. So so keep that in mind. So anyway, let me go ahead and take this out of the box and show them to you guys, and I'll do the usual tear down and then onto the truss test. So these come in EMAX's usual box, and they also come with the scratch serial number, so you don't get counterfeits. So that's pretty typical of EMAX now these days, since there's a lot of counterfeit operations out there on eBay. So make sure you get your original EMAX motor. So this is the usual EMAX plastic box. As usual, also lately EMAX has been including extra hardware. They do include an extra shaft retaining screw with the washer. So that's good. Everything's pretty clearly labeled. Mounting screws for 4mm arms, and also another set for 3mm arms. Here's the motor. It comes in this nicely padded box, and as you can see, pretty nice looking motor. And it also comes with aluminum nylock thread, so that's nice. Pretty much all you need. New design from EMAX, since they're going for lightweight on this one. So as you can see, the bell is been designed to make it as light and as strong as possible. And you can see that they've gone to great lengths of designing the spokes here, as you can see, for lightness. they've actually done, there's like a groove right here, so this is kind of like a C channel, so that kind of instead of being just a flat spoke, they've done this kind of U channel shape, so that's kind of like a structural shape, you know, so it helps keep weight low and while maintaining strength. So very nice. Also color scheme is all black with polished aluminum edges there, and looks like they have a textured propeller base here, so that the bell grabs the propeller, so that's pretty good. And another thing you can see also is that the shaft is an integrated shaft, and they do have I guess that's part of the motor shaft. It's inserted through the propeller shaft, so that helps with strength. It's kind of like a composite shaft with hardened steel and the aluminum portion. And as you can see, the base is pretty minimal, very small, and they went with the 16 by 16, so they're not doing 16 by 19 anymore, which is pretty good. I think you really don't need to have those two different patterns, but of course all the frames now will have to start to adapt to this new pattern, 16 by 16, so that's good. Also helps keep the weight low. Once the screw is out, let's take this apart and we'll see it up close. Okay, so here's the stator for the 2207. They're using 0.15 millimeter silicon steel laminations. And here's the stator height, 7 millimeters, so no surprises there. And as you can see, also pretty neat windings, typical from EMAX. Very high quality on the overall build of the motor. Multi-strand wire, as usual from EMAX. They like to use multi-strand wire, and does pretty well with that type of wire, as we've seen with the 2306 and the 2205 from the RS series. And the shaft on these motors, they've decided to go with 3 millimeter shaft. I guess that's to keep the weight low. So no 4 millimeter shafts. So that does help keep the weight low. So it's supposed to be hardened steel, so should be pretty strong, same as the RS 2205. And these are arc magnets, and they're supposed to be N48SH arc magnets, so a little bit lower strength than the usual N52 magnets that other motors have. So you know that they've done that on purpose. I imagine that helps keep the possibly keep the weight low, and also helps with the performance of the motor. I guess they're looking for a more smoother performance. When they design motors, they can play with the magnet strength and the air gap and the laminations and the copper. So altogether, you know, they're able to match performance as if they were using N52 magnets or you know, different stator and all that. So no worries there. So pretty interesting. They went with N48 magnets. So as you can see, there's the insert on the shaft. So it's kind of like a composite shaft with the hardened steel core and the aluminum sheath on the outside, which is part of the bell, part of the bell cap, and a pretty good amount of glue, as you can see there on the magnets. So no way those magnets are coming off. That's pretty good amount of glue. Bearings are NSK bearings, Japanese bearings, so those are supposed to be really good quality, and these are 3 inner diameter and 3 millimeters, and then 8 millimeters on the OD, the outside, and I believe they are 3 millimeters. The thickness of the bearing is 3 millimeters. So there you see the base, pretty, not overly thick and not overly thin either. Pretty good amount of material there. So it's the, you know, what we come to call the naked bottom. So another advantage of the naked bottom is that when you're mounting the motors now, you're able to see and make sure that the screws don't hit the winding. So that's one of the good things besides weight reduction on this basis. So no more screws messing up the windings and causing shorts. So that's good. The 2206, it's very similar. I mean, almost identical. So the only difference is gonna be the height of the stator. There they are for comparison. You could just barely see the difference between the two. Other than that, they're pretty much the same. They're using the same design on the bell and the bell cap. Everything else, the base, everything's pretty similar. Same type of magnets and windings, and also the shaft retaining screw is the same. So let's put it together and put this on the truss stand. So these come with about 125 millimeters worth of wire for the motor leads, and these they're using 18 gauge wire, so a little bit thicker than others. And what they're claiming is that by going with the thicker wire, they're able to get current more efficiently all the way to the motor from the ESC. And they're claiming 5%, up to 5% performance increase. So that's good, I suppose. To have to agree that thicker wire is usually better, less resistance. Those add a little bit more weight, but not a lot. You know, just a couple of grams. It's not bad. So let's see what the motor weighs with these thick wire with 125 millimeters worth of wire. Okay, so with the 125 millimeter worth of wire, the 2207 weighs in at about 35 grams. So 35 grams, we cut the wires to about 50 millimeters. We would take out that much. So 35 grams minus 3.4, it's about 31.6. So 31.6 grams with the 50 millimeter worth of wire. So 1.6 wire should be what the 50 millimeter wires weigh. So pretty good weight for the 2207. Around around 31 to 32 grams with usable wires. The 2206 is supposed to weigh 28 grams without any wires. So let's see what it weighs with the 125 millimeter worth of wire. It's 32.6. So 32.6 minus 3.4 is about 29.2. So pretty good weights for these motors. They're certainly light, so they'll go well with all the light builds that you guys are doing. So pretty good option for those of you that want the ultimate light quad. Alright, so let's move on to the truss test. Alright, so here we have the Truss test results for the EMAX LS2207-2550KV. The motor came in pretty close to the 2550 kV. I measured at 2530, so pretty close overall. That's pretty typical. Sometimes the motors will be slightly lower or slightly higher than their spec kV value, so that's pretty good. So this motor overall is a pretty solid performer. As you can see, the motor's getting pretty good thrust on the 5-inch props, pretty much breaking the 1500 grams on the HQ5043. On that same prop, if we go to 5S, a pretty outstanding 2064 grams out of this motor. Reasonable amps, I think. You gotta keep in mind that these are static thrust, so the amps are gonna be exaggerated. You know, it's a single motor on a power supply with very constant voltage that doesn't sag. On top of that, we have a lot of recirculating air on the propeller when you're in static. Once the motor is flying, of course, these amps are gonna go considerably lower, up to 35, even 40% lower. So that's pretty manageable on 5S. And a lot of people run 2207s with this KV on 5S, no issues. So that's pretty high for this motor. Very good thrust out of this light spec motor. As we move on to the more aggressive props, of course, the thrust gets higher. Still, the amps are pretty manageable, I think. If we apply the 35 to 40% lower in flight. Also, you know, that's going to be burst amps, so you're only going to see them for a very short time on some situations when you punch out or when you're getting out of the dive, so that you're only going to see it for a second or two at most. On the 6-inch props, still the motor keeps making power, nearly 2 kilograms. Didn't quite break the 2 kilograms, but it's still very respectable. 1939 and 1945 out of the 6040 and 6045 prop. So overall, a very good motor, very good entry from EMAX. So this motor is pretty much performing like any of the other top 2207 motors of the same kV. So very good option for you guys, you know, that want to get a very fast motor. These LS series should become pretty popular on fast builds. If this motor proves to be very durable and reliable, it's going to be a good seller for EMAX. So there you go. That's the thrust test for this motor. Hope you find the data useful, and until the next video.